Okay, so we're continuing with our examination of atoms. And in the previous class, we talked about what makes up an atom, the atomic models over history, things like that. So now we're going to get into some more specifics. So last class, we talked about things you probably already knew, like atoms are made of protons, neutrons, and electrons. So now we're going to increase our depth of knowledge. And we're going to talk about atomic number and atomic mass. So the atomic number is the whole number value on the periodic table. And that's a terrible number sign. Let's erase that. It's the whole number value on the periodic table. It's also, most importantly, the number of protons. And I'm going to call protons P plus. I like to do shorthand. So P plus is protons, number of protons in the nucleus of an atom. And this number defines the element. So any atom in the entire universe that has one proton is hydrogen. Any atom in the universe that has two protons is helium. Any atom that has three protons is lithium, so on and so on. So this number here defines the element. So the number of protons defines the element. So all atoms of an element have the same number of protons, but can have a different number of neutrons. And so we do like the N with a little zero over it for neutral. Or for neutrons, I mean. So, and also, if an atom is neutral, which means it has no net charge, well then, the pluses have to equal the minuses. So the number of protons equals the number of electrons. Because the number of pluses have to equal the number of minuses. So for a neutral atom of oxygen, well, we know because it's oxygen, we look on the periodic table, it has an atomic number of 8. So for a neutral atom of oxygen with 8 protons, so 8 pluses, there must be 8 electrons as well. Okay, so going back to what we learned, the mass of, ooh, there's a cool hawk. Sorry, I got sidetracked. The mass of an atom is almost entirely in its nucleus. And what we say is that each proton and neutron luckily weigh about the same amount, and we call that an AMU, or atomic mass unit. And electrons weigh approximately 0. So it's like 1/1800th of an AMU. So when we're counting the mass of an atom, we can assume that the mass of an atom is equal to the number of protons plus the number of neutrons, because the electrons don't really add anything into that. Okay, so the average mass. On the periodic table, you'll notice that the mass of an atom is that decimal number. The average atomic mass is that decimal number. So the average mass from the periodic table is usually close to the mass number of the most common form of that element. Right. So we've learned that protons define the atom, but they can have different numbers of neutrons and still be that element. So carbon can have carbon most commonly has 6 neutrons to go along with its 6 protons, but some carbons can have 7 neutrons, some carbons can have 8, and it still is carbon. So an example here: how many neutrons are you most likely to find in an atom of phosphorus? Well, phosphorus has equals number 15. So it has 15 protons. The average atomic mass is 30.97. So rounding that off, it equals approximately 31. We can call it 31. So we know that protons plus neutrons is equal to the mass, which is 31. We know that we have 15 protons. So the most common phosphorus atom has 16 neutrons. So most of the phosphorus atoms in the universe will have the 16 neutrons to go with the 15 protons that it will always have. So just to summarize, to figure out how many neutrons are most likely present, you round off the atomic mass and subtract the number of protons. I'll put that in red. To find most likely number of neutrons, 1, round off average, running out of space, mass, and 2, subtract protons. Okay. So, wrapping up, how are the atoms of one element different from those of another? So, answering that question, each element has one more proton than the element preceding it, but that doesn't really answer our question. That just tells us a little bit about the organization of the periodic table. The atomic number of an element is the same as the number of protons in the nucleus of each of its atoms, but atoms of one element can have a different number of neutrons, which will be coming up in a future slide. So in a neutral atom, the number of electrons is equal to the number of protons. The pluses equal to minuses. We're going to find that that's not the case a lot of the time, but that means the atom is no longer neutral. So the mass of a proton is 1 AMU. The mass of a neutron is also 1 AMU. The mass of an electron is negligible. So to find the mass of an atom, you simply add the protons and the neutrons. And here, I didn't give you this note earlier, but atoms of the same element that have 2 different numbers of neutrons are called isotopes. And the percentage of each isotope of an element that occurs in nature is called the percentage, the natural percent abundance of that substance. And next time we're going to talk about isotopes a little bit more.